All right, let's talk about a buzzword you've probably seen everywhere in AI lately, the harness. We're going to break down what it is and then dive into this really cool project out of Stanford where AI is literally learning how to build better versions of itself. Okay, so let's just get right to it, because if you've been scrolling through tech Twitter or Reddit, you have absolutely seen this question. The word harness is popping up everywhere, but it means a bunch of different things, and it can get super confusing fast. So if you go and Google harness right now, you're going to find a few different things. There's Harness, the company, which is a big DevOps platform. There's the BioHarness, a medical gadget. We're going to ignore both of those today. We are zeroing in on that third one, the AI concept, because that's where things get really interesting. So what's the easiest way to wrap your head around an AI harness? Well, I think the best analogy is to think about the difference between a brain and a body. It's all about connecting that raw intelligence to actually doing something in the real world.
I love this quote I saw in a developer discussion. It just hits the nail on the head. An AI model all by itself is basically a brain in a jar, right? It's incredibly smart, but it can't do anything. The harness, that's the body. It gives the brain hands, eyes, and a way to interact with everything around it.
So to get a little more official, the harness isn't the AI model. It's all the infrastructure built around the model. It's kind of like a translator and a safety net rolled into one. It takes what the AI wants to do, gives it a safe environment to try it out, captures everything that happens, especially the screw-ups, and then feeds all of that raw feedback right back to the AI so it can learn and figure out what to do next. And this, right here, is the game changer. See, without a harness, an AI is basically just a fancy suggestion engine. It can write a piece of code for you, but it has no idea if it actually works. But with a harness, it becomes a true agent. It can execute that code, see the big red error message, and immediately go, oops, let me try to fix that. So this whole process runs on a really simple but super powerful feedback loop. The harness lets the AI run a command in a safe sandbox. Then it grabs every single thing that comes back, the good, the bad, the ugly, and shoves that raw data right back to the model. That's the secret sauce. That's what turns an AI from just a thinker into a doer. Okay, so now we know what a harness is. But what if you could use a harness to build a better harness? Sounds a bit meta, right? Well, that's exactly what a team of researchers at Stanford did. They took this idea and just ran with it, creating something they call the meta harness. And the core idea behind their whole project is, when you think about it, kind of brilliantly simple. Right now, incredibly smart people spend thousands of hours carefully designing these AI bodies. So the researchers asked a pretty profound question. What if an AI could just do that job for us, and maybe even do it better? And yep, that's the meta harness. It is literally a harness designed to optimize other harnesses. It uses a powerful coding AI to watch another harness try to solve problems, figure out where it's weak, and then automatically rewrite its code to make it better. It's AI building better tools for other AI. It's wild. But how? What's the big secret here that makes this work? Well, the real breakthrough, the key difference, is all about how much information the AI gets to see. Think about it like this. Trying to optimize an AI system before was like a mechanic trying to fix your car, but the only information they have is its top speed. They get a single number or a short summary. But MetaHarness, that's like giving the mechanic the full, unedited, minute-by-minute diagnostic log from the engine for every single trip. They get to see everything. And we can actually put some numbers on this. Before, the best methods were working with maybe around 26,000 tokens of context. Now that sounds like a lot, but in a complex program, that's just a tiny snapshot. It's enough to know that something broke, but not nearly enough to understand the full story of why. But MetaHarness, this just blows that completely out of the water. By giving the optimizer access to a whole file system of logs, it can look at up to 10 million tokens. For a single step. This isn't just a small step up, it is a gigantic leap. It's the difference between seeing a car crash and having the black box data from the flight recorder. That level of detail is what lets the AI find the root cause of a failure with surgical precision. Okay, so the theory is amazing. A massive fire hose of data for the AI to learn from. But did it actually work? Can an AI armed with all this info really outperform a human engineer? Well, the results are kind of crazy. I saw this comment on a thread about the paper that just perfectly captured the feeling. It said,
Crazy to imagine the sheer number of man-hours from very intelligent people that were spent just to get beaten by an AI in a loop lol. And honestly, yeah, that pretty much sums it up. But let's look at the hard numbers, because they really tell the story. On this really tough coding benchmark, the harness that Meta Harness automatically discovered scored a 37.6% success rate. That put it right at the top of the leaderboard, beating out Goose, which was one of the best systems tuned by humans. And this wasn't some fluke. It also crushed the baselines on the bigger, badder Claude Opus model. It boosted math reasoning accuracy by nearly 5 points. For text classification, it got almost an 8-point bump, while, and you gotta hear this, using 4 times fewer tokens. So it's not just smarter, it's way, way more efficient. So let's zoom out. What's the big picture here? What does all this mean for the future of AI? Well, it really feels like we're watching a fundamental shift happen in how we build these things. You know, for a while now, it's all been about prompt engineering, right? Finding that perfect magic spell of words to get the AI to do what you want. This research is basically saying that's not the future. The next big frontier is harness engineering. It's not just about what you say to the brain, it's about what kind of body you build for it. And this really changes everything. Suddenly, these harnesses aren't just some messy one-off code hidden away. They're becoming real, shareable tools that you can version and improve. We can now automate the whole search for better agent designs, which lets researchers run much cleaner experiments to figure out what really works. And ultimately, it means we can start building AI systems that are far more reliable and that we can actually audit. And that leaves us with this one final, kind of mind-bending question. For so long, we thought the biggest bottleneck in AI was just making the model, the brain, smarter. But this research shows that the AI can now start building its own, much better body. So if the model can improve itself and the harness can be improved by the model, what's the new bottleneck? What's the next big wall we have to climb? Is it compute power? The quality of our benchmarks? Or something we haven't even thought of yet? And that right there, that's probably the question that's going to define the next chapter of AI.